Hi, this is the tutorial 1.6 part 3. We're going to carry on with some more dimensional analysis, and this time we're going to be comparing areas and volumes. There'll be some pictures for you to compare things to, to make sure your thinking is nice and clear. So let's just get to some examples. Here's the first question. What is the area of the red squares shown in centimeters squared? So you look at these red squares and say, well, I really can't tell how big they are, but then down here it shows you that one of these little red squares would fit in the way shown into a big decimeter squared. Well, you can tell what this length dimension is here because there are 10 centimeters in a decimeter. So this little red square must be a centimeter square. They ask how many we have. Well, obviously we have 8 of them. We just count them. There's 1, 2, 3, 4, 5, 6, 7, 8, and we're done. The area shown here is 8 centimeters squared. So that the only issue here was interpreting that diagram. Apart from that, it was trivial. So let's look on the next example. This time it's the same basic question. We still see 8 centimeter squares from before, but we would like to know what the area is in square meters. So the first part is the same logic. I can see that that little length dimension here is 1/10 of a decimeter, so those must be centimeter squares. And now comes the new part. I have the 8 centimeter squares. That's how many little red squares I have. But what is that in square meters? I remember that there's 100 centimeters in a meter. So I imagine making a 1 meter by 1 meter square and asking myself how many centimeter squares are in that. It would be, the dimension would be in centimeters, 100 centimeters by 100 centimeters, which of course is 10 to the 4th or 10,000 centimeter squares in a square meter. Do I divide or multiply? Well, I can tell. I just let the units guide me. So the centimeter squares are going to cancel if I divide by 10 to the 4th. So that must be correct. There are 8 times 10 to the negative 4th square meters in those little red squares that were represented in the diagram. The next one here, back to something perhaps a little bit trivial. It just says what is the area in centimeter squares. Well, you can see those are centimeter squares as before. And just count them. There's 3 by 10. There's 30 of them. So the answer must be 30 centimeter squares. Okay, now the next couple are a little harder. So here the question is, what's the volume of the little red cubes in meters cubed? You slow down for a second and say, well, let's see, I can see that there's 5 cubes here, but exactly how big are these cubes? Once again, I can tell if from here to here is a decimeter, the length of one of those cubes, or width or height, just one of the dimensions, must be a centimeter. So those must be centimeter cubes. So I kind of get it. I say, okay, 5 cubic centimeters. And I know if I could actually remember there's 1,000,000 cubic centimeters in a cubic meter. But let's actually write that out with some confidence. So the logic here is just to make sure you recognize that this length of one of these cubes is 1/10 of a decimeter. Therefore, those must be centimeter cubes. And now the part about the cubic relation. We say, okay, 100 centimeters are equivalent to a meter. And therefore, if I make a cube out of a meter, that is a 1 meter by 1 meter by 1 meter cube, what would that be in centimeters? It would be 100 centimeters by 100 centimeters by 100 centimeters, or 10 to the 6 cubic centimeters, 1,000,000 cubic centimeters in a cubic meter. Again, do I divide or multiply? Let the units guide you. If I've got 5 cubic centimeters, I must have to divide by 1,000,000 to get the number of cubic meters, a fraction of a cubic meter. Answer is 5 times 10 to the minus 6. Okay, I think there are 2 left, or maybe there's just 1 left. So this one is a little bit trickier. Let's look at this one. The same basic drawing, it looks like. You've got these 5 cubic centimeters, but the question is different. It says, if the density of this stuff, this material shown here, is 524 kilograms per cubic meter, what is the mass in grams? So it's nice to kind of visualize where we're going so you don't get lost along the way. We already know how to figure out what the volume of this is in cubic centimeters. We just did it in the last problem. In cubic meters. Once we have it, what do? Well, we multiply by the mass, 524 kilograms per cubic meter. That will tell us the mass, at least in kilograms, and then we'll have to turn those kilograms into grams. That's a lot of steps there. You could easily get lost, but if you use the units, the dimensions, and therefore dimensional analysis to guide you, we should be able to manage it pretty well. So first, this first logic, yes, we get that there's 5 cubic centimeters here, like we did before, and now comes the new part, letting the units kind of get to solve the problem for us. So let's see what we're doing here. 5 cubic centimeters is the volume. I have to divide by 1,000,000 to get what fraction of a cubic meter it is. So I take 5 divided by 1,000,000. I have 5 times 10 to the minus 6. That's the number of cubic meters. Now I say, okay, this thing has a mass of 524 kilograms for a single cubic meter. So when I multiply the results of this calculation by 524, I know the mass of those 5 cubes in the units kilogram. And I'm almost done, but I have to now multiply by the number of grams per kilogram to finally get the answer I'm looking for, which is the number of grams, and it comes out to 2.62. So this one, especially when you just do it on your own, it can really feel quite a bit more difficult than what we've done. So let me just kind of make sure that we see how you would get there step by step. You'd start with the volume of cubic centimeters, and you say, how am I going to get 2 grams? Well, I'm going to have to go through this, which is not really a conversion factor. It's a density. It's the mass per volume of this material. So you can tell the volume that you have can't be in cubic centimeters. It has to match with the volume given in the density. That is, you have to get to cubic meters. So that tells you that you got to go to cubic meters. Once you're there, this is kind of like that bridge, the way we had that bridge between the English and the metric system. This is going to get you over into masses if you know volumes. And notice there was no need here to use a formula, density equals mass over volume, and solve for the mass. We didn't have to do that. We just let the ratios guide us and the units as we do the ratios. Divide by or multiply by the kilograms per cubic meter. You now know the mass in kilograms, and then there's another step left, is to get rid of the kilograms and turn them into grams. If I talk too much, maybe I'm going to make it seem more complicated than it is, but you do need to practice these. If my experience is any guide, most students need a few minutes of practice before they feel comfortable with this kind of problem. Okay, good luck with that, and we'll probably have to practice 1 or 2 in class together just to make sure that you can set all these things up on your own. Okay, we'll see you in class. Good luck.